in classrooms and from our directed, targeted testing sessions, we were able to see kind of two things emerging that we needed to improve. One was the product is a little expensive. It limits us from certain markets that we know we could have a great impact because our product has real educational efficacy and can have a real impact in an everyday classroom. So we knew we needed to drive costs down further, even more. And so that's currently what we're working on with this unit, is kind of thinking about where we can save costs. So removing even more mechanical hardware, integrating more of the mechanical features within the wood design, and relying less on mechanical hardware for it. Additionally, we're looking at integrating electronics even further. So in this version, we'll be integrating our driver board with our speaker system to save costs. But we still have the deconstructed speaker because we saw the positive learnings kids saw from connecting and assembling their own speakers. And so it's a balance act of like all the wins we achieved with this unit, still trying to hold them at the core, but still driving lower costs. And it's a constant back and forth, and it's a challenge. We're still in the process. It takes a while. What else? So another thing too is, earlier I talked about how the Piper, the Raspberry Pi was the center of the experience. And what we saw actually was most classrooms use 3 students to a kit. And so we wanted to start designing the layout to encourage more of those stations, more of distribution of roles based on what physical components they interact with. And we actually found that the controller, which is where they interact with more, is the center of the kit. And so we put in the center so it's easy to have it here, to switch over here and here, so all 3 students can interact. And then the mouse can interact on the side, and then storage collection and organization can be on this side, and then it's easy to switch between the roles. And so that's some kind of the huge wins we're working on right now, and the opportunities that we're developing that you'll see come out new and next. We saw at a conceptual level areas where we can improve how we actually educate this hands-on experience. Because at the core, Piper teaches young learners that to create and to use technology, it's all about touching and interacting and being hands-on. And we needed to give them more autonomy, more ownership of the experience. And so we developed a controller experience that's purely modular. So the pieces can be removed and switched around. And so they can have control and decisions of how they want the physical device to be and feel, but also still feel like they can hack it and drill into it with the same great wood that we use. The core concept of the controller is it's a prototyping platform. So it teaches them the basics and the early ideas of circuitry and coding, but it takes it to the next level to give them real life problem solving scenarios where they think about, okay, I am in a community and I need to design a stoplight situation. How do I design a device or a lighting system, and getting them to design in the real world, not only on the screen. This product also is unique and different because it connects to any computer. It's a web-based software experience, whereas this is a desktop experience. The reason we did that is because we wanted to reach more audiences and have more universal appeal. So not everyone can afford a full computer kit, but they can afford a controller and then connect it to their classroom-issued Chromebook.